All right, in section 2.1, we're going to start to look at functions and graphing. And so we're going to introduce some terms that hopefully are not necessarily new. Hopefully you've seen them before, but if you haven't, that's fine too. So the first thing we're going to talk about is domain. And domain is going to be the list of x values that the function can take on. So the domain is the set of x values. And for an ordered pair, like they've given us here, an ordered pair is always x first and then y. So it's pretty easy for this first one. You just have to grab the first number from each ordered pair. And that would be your domain. So we'll record these here. We'll just type in 3 and 6 and 9 and minus 9. Okay, similarly, the range is the set of y values in the function. So in an ordered pair, it's just the second number. So we just grab the second number from each ordered pair and record those. 3, 6, 9, and minus 9. Now, this is just a coincidence. This is they don't always have to match, but in this particular case, we have kind of a famous function. It's called the identity function, where it's y is equal to x. So you'll have those numbers will always match. In fact, it's one of the simplest graphs we can have. Y equal to x is just a straight line that goes through the origin at 45 degrees, and it goes off to infinity on either side. This would be the graph. And you can see it here too. So we have, when we had 3, when we had 9, what did we get for the y value? We got 3 high, we got 9 high. So this will just have matching numbers, so any x you pick, you'll get the same y. Okay, now it says, does this represent a function? Well, there's lots of ways we're going to, a few ways we can test this to see. For now, I'm just going to say this. So imagine I don't have that picture drawn there. Okay, so let's imagine we don't know what this thing looks like. Does it represent a function? It will be yes if there are no repeated x values. Okay, now we're going to expand a little bit about that here in a little while, of why don't I want repeated x values. But for now, let's just say all you have to do to answer this question is look at your domain and say, is there anything repeated? 3 is different than 6, is different than 9, is different than minus 9. So notice you do have technically 2 9s there. One's plus, one's minus, so they are different. So we have no repeated x values, therefore, yes, it is a function. For problem 2, it's very similar. We'll underline in blue again the domain, the first number. So the domain, notice I have a 1 and a 1 and a 1 for those 3 ordered pairs. The range would be the second numbers in each of these. So we have 8, 9, and 10. And we're going to immediately notice that we have repeated the 1. We have repeated x values. And if you do have repeated x values, then it's not a function. So that's how that would look. So basically, we've got x is 1, but now I could have 3 different possible y values, 8, 9, or 10. And the idea of a function is it should be 1x gives you 1y. So in this case, 1x is giving us 3 y's, and that's going to be a problem because now I can't predict. So I can't predict, okay, when x is 1, my function is going to produce an 8, or maybe it produces a 9, or maybe it produces a 10. That's going to be an issue for us. Okay, for 3, I'm going to actually introduce a what we call a parent graph, and that is of a circle. So a circle is defined by x squared plus y squared equals what we call the radius squared, where r is equal to the radius, which is half of the diameter of the circle. So this is 1/2 times the diameter. And we know that the diameter is going completely across the whole circle. So the radius is half of crossing the circle by half. Okay, so if we have this lined up like this, then I can tweak this equation ever so slightly and say, okay, this is x squared plus y squared, but on the right, let's make it, instead of 16, let's make it 4 squared. And then we can see that this is a radius equal to 4. I should put something here as well, that this is a circle centered at the origin. So that's important too. Okay, so let's see what this thing looks like. Draw our Cartesian grid, x and y, and I just have to record 5 tick marks on each one. The radius of 4, we just have to carve out. We have to go 4 units from the origin. So we'd say 4 this way, vertical, 4 to the left, which would be minus 4, and then 1, 2, 3, 4 down, which would also be minus 4. And for a circle, we just have to go in and put a dot at those 4 spots. So, well, first let's put a dot at the origin. So it's centered right here. Then we're going to put a dot at plus 4, minus 4, and minus 4. And then to make the circle, we just try to smoothly connect those dots. Circle. But this whole thing is asking, is y a function of x? Is y a function of x? And at this stage, I'm going to introduce what's called the vertical line test. You've probably seen this before, but if not, let's go through it. So we call it the vertical line test. And it says this: y is a function of x if any vertical line passes through the graph at no more than 1 point. Is a function of x, I forgot the x here. Y is a function of x if any vertical line passes through the graph at no more than 1 point. So it's wordier than it needs to be. You'll pick up on this very quickly. So all you have to do is start drawing vertical lines. They have to be perfectly vertical lines. Now if I miss the graph, that's okay. So I haven't hit anything yet, that's okay. So it doesn't disqualify this graph as being a function of x yet. And I draw another one I miss, and then I draw one more and it hits 1 point. So if it hits just 1 point, that's good. That's what we want. We want a vertical line to hit only one spot. But then anywhere over here, so let's say I draw one right here, right at about minus 1.5, I get 2 y values. I get a y value up here, and I get a y value up here. Since this would be 2 ordered pairs, I have x is minus 1.5, and then up here, my y value is like, just reading it off the graph, maybe 3.5. Solve and get those numbers exactly, but let's just estimate them for now. Positive 3.5. And then at minus 1.5, there's a second one down here at minus 3.5. So we have repeated x values again. So the vertical line test is really searching out, hey, do I have repeated x values? Do I have one x number that gives me 2 possible y values? And again, the whole point is, I don't want that. So I want to know if I give you x equals minus 1.5, that you write to me that y value should be this number, and only that number. It can't have a possibility of being 2 numbers. So this one, and this is called, when you hit 2 points like this is called failing or it fails the vertical line test. So if it fails vertical line test, it is not a function. So we answer no. Okay, for 4, our goal, I should mention our goal. So when you're working with problems like this, your goal is to get y equal something. So x's, numbers, y on one side, everything else on the other. Now, we tend to like y to be on the left side, so we're going to adjust this problem ever so slightly. We're going to say, let's just swap everything. Let's call it y squared equals x plus 7. Just kind of like moving the two sides. And you can do that anytime. You don't have to change minus signs or anything. Just swap them both, and everything will work out. Just make them look the same. And now we say, okay, how do I get rid of that square, that y2? To get rid of a y squared, you hit the square root. Now, this is important. When you're drawing a square root symbol, if you're ever drawing a square root symbol, you need to add plus or minus. In fact, let's jump to problem 5. Notice they have a square root symbol in number 5 already. You did not draw it, so you do not need to add plus or minus because you did not write that one. So that's kind of a preview of 5. Okay, but let's look at this one still. So this square root and this 2 will cancel. You're left with y. You actually have plus or minus the square root of x plus 7. To solve this, we're going to pick x's and solve for y. So let's pick some x's and let's solve for y equals square root of x plus 7. Take minus 7, I'm going to take minus 3, I'm going to take 2, and I'm going to take 9. And you'll see why I picked those x values in a second. So when you plug in minus 7 in here, you get plus or minus the square root of minus 7 plus 7, which is plus or minus the square root of 0. The square root of 0 is 0. So you get plus or minus 0, but there is no minus 0, so you just get 0. It's 3. Plus or minus square root of minus 3 plus 7. 7 take away 3 is 4, so you get plus or minus the square root of 4. Square root of 4 is 2, you get plus or minus 2. Let's try x is positive 2. 2 plus 7, plus or minus the square root of 9, plus or minus 3. Square root of 16, which is plus or minus 4. So I kind of picked x's a little bit cleverly there to get perfect squares. So 0, the perfect square is 0. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. But we can still get the graph pretty nicely from this. So 2, 3. Here's minus 7, and we had minus 3 was a point, and 2 was of interest. 9. And in the y-axis, we had minus 1, minus 2, minus 3, and minus 4. 2, 3, and 4. So we have a point at minus 7 in the x, we go 0 in the y, so it's right here. When x is minus 3, we have 2 in the y, so we're right there. X is 2, we have positive 3. X is 9, we have positive 4. And if we connect those dots, so it's going to keep going. Okay, so we didn't have a negative. going to go off to infinity like that. So I missed the graph, that's fine. It could still be a function. I hit exactly 0, I'm still okay. It could be a function. But this one right here, x is minus 3. Notice it's the same x value, minus 3. I have two possible points. I have 2 or minus 2. And so this is going to fail vertical line. It's a no. It is not a. Now, what's interesting about this is we can immediately do problem 5 because problem 5 is the same problem, but there's no plus or minus out here, so it's only the top part. We're going to start at minus 7. It's going to be just the blue line. So it's going to start here and go up like this to infinity. This is the same. This graph right here is the same as what we just did above, but it's just the top part. And now we can come in and say, okay, vertical line test this. Miss it, that's fine. Hit it at 1 point, that's fine. But all these are going to be 1 point. So any vertical line I draw, I'm hitting 1 and only 1 point. 1 there, 1 there. So that's a yes. So this one passes the vertical line test. Okay, for problem 6 now, they want us to practice with putting numbers into a function. So when I have y as a function of x, that means we can plug in x, x to get a y. So we're just going to practice doing that. So when it says h of minus 3, all of these things that they have here, they're all x's now. So anywhere I see an x, I'm going to replace it with minus 3. So our function is x to the 4th plus 7x squared plus 5. But now I'm going to replace those x's with minus 3. So we're going to have minus 3. You want to use a parentheses here. Stop and look at a principle here. So when you have any number that's negative and you raise it to an even power, that minus sign is going to go away because what you have is you have pairs of double negatives. So you're going to get just the number to that same even power. If, however, you have some negative number and you raise it to an odd power, what's going to happen is the double negative cancellation, you'll have a bunch of double negatives, but then there'll be one odd, one out. There'll be one minus sign that doesn't get canceled, and it's going to stick around. So it's the number raised to the odd power with a minus sign. So the minus sign will stay. So in this case, because this is a negative number to an even power, in fact, both of them are even, signs are going to go away, and you're just left with 3 to the 4th. This is times 3 squared. So we're going to get 81. 3 squared is 9 times 7 is 63. That's a 5. Just have to record the number 1. It's actually an ordered pair. So what we actually could graph this. We have a point. This is minus 3. We have this point way up here. So the intersection of minus 3 and 149, there's a dot. Let's try minus 1. So h of minus 1 would be minus. Oh, do use your parentheses. If you don't use parentheses on these minuses and you just plug it in your calculator, it will do it. It will do it correctly, but it will give you the wrong answer. Without parentheses, if you type minus 3 to the 4th on your calculator, it's going to give you minus 81 because it's going to correctly do the order of operations. So the order of operations are 3 to the 4th, which is 81, with a minus sign. If you type in minus 3 to the 4th with parentheses in your calculator, it will correctly give you what you want, the right answer, positive 81, because it's going to take that entire number to the fourth power, not just the number, and then apply the minus. Okay, so this is going to be plus 7 times minus 1 squared, plus 5. This is just going to be 1, 7 times 1, and that's going to be 13. So we have another point when x is minus 1, and we have, because of the scale, 13 here. So we have a blue dot at minus 1, comma 13. Okay, and then we have, so now they want us to use not numbers but letters, and that's fine too. You can pass letters even into these functions. So we have minus x, so h of minus x. Anywhere you see an x, write minus x with the parentheses. But same argument. This is just a negative number raised to the fourth, so what did I write up here? I said if it's even, we're just going to get that number back with it being positive, and it will stay. Same thing here. This is going to be 7 with the x squared. The negative goes away. Plus 5. So we just record that. So the function is x to the fourth plus 7x squared plus 5. And we're going to notice that that's the same that we started with. So x4 plus 7x squared plus 7x squared plus 5 plus 5. When you get things to be the same after plugging in minus x, this is called an even function. I'll study this more, but it means it has symmetry. In fact, if we picked more letters and numbers, this thing would look like this. It's going to come down, cross here at 5, and then it's going to look exactly the same. I didn't draw it perfectly, but basically the left side and the right side are going to match. It's going to have this symmetric nature to it. It's called an even function. Okay, and then the last one, kind of the trickiest one maybe, is they want us to plug in two things, 3 and an a. So everywhere we see an x, we're going to write in parentheses 3a. Now the tricky thing about this is you have to distribute that 4. So that 4 is going to go on top of that 3 and the a. This 2 is going to go on top of that 3 and the a. So the powers are going to distribute. So we get 3 to the fourth times a to the fourth plus 7 times 3 to the second times a to the second plus 5. 3 to the fourth is 81 with an a to the fourth next to it. 3 squared is 9 times 7 is 63 with an a squared on it plus 5. And that would be the answer here. 81 a to the fourth plus 63 a to the second plus 5. And I had a student in the face-to-face class ask, can we simplify this further? Can we combine anything, these a's? And the answer is no, because if these powers don't match, you cannot combine. They don't match, so you can't combine. If they did match, you could. If they were both a to the second, then we could add those two numbers in front. Or if they were both a to the fourth, we could add those two numbers in front. But because they're different, we cannot combine those. And that will be all the steps on this one. Okay, this is the one I usually have my students work in class on their own, just to get some practice plugging in these numbers. So, but let's do it together here. So we have anywhere you see an r now, so the variables are, we're going to replace it with these three things. So we have 8 minus 8, and then x minus 8, all of that into that r. First one, we'll replace the r with negative 8. And be careful, a lot of my students wanted to write the minus 6 underneath the square root sign. Notice the square root sign ends right here. It does not include that 6. So try not to make that mistake. Okay, minus 8 plus 8 is 0. So we get the square root of 0 minus 6. Square root of 0 is 0. So 0 take away 6 is just negative 6. Okay, let's try positive 8. Everywhere we see an r, we instead write positive 8. So instead of r plus 8, we have 8 plus 8 minus 6. This is the square root of 16 minus 6. The square root of 16 is 4 minus 6 would be negative 2. And the last one, we're replacing r with all that, x minus 8. So it would be the square root of r, but we're replacing that with x minus 8. Then there was a plus 8, and then there was a minus 6. Well, this minus 8 and plus 8 are going to cancel each other, so you're just left with square root of x minus 6. And that's the furthest you can go. So you can't combine these in any way. Radicals and numbers are apples and oranges. So you're just going to write square root of x minus 6. Okay, in number 8, we're going to start to do some graphing. So we're going to pick some x values and then solve for the y values and get our ordered pairs so that we can get this picture ourselves. So I'm going to do this first one, f of x, in blue. So I'm going to pick some x values and solve for f of x. Okay, so you can pick any x values you want. I tend to pick the same ones when I can, and that way it's faster. I don't have to think about it. So I tend to pick a couple negatives. Usually small numbers are nice, so there's less challenging arithmetic. Always take 0, and then I pick a few positive numbers. So these 5 are typically the ones I usually pick. And we just have to plug minus 2 in for x. So it's going to be minus 2 times minus 2, which is double negative cancellation. You're going to get positive 4. Minus 2 in front times x, but x is minus 1. Double negative cancellation, 2 times 1 is 2, and the minus goes away. Minus 2 in front, x is 0. Anything times 0 is 0. Minus 2 in front, x value is 1. Now the minus is going to stick around, so we're going to have minus 2. Minus 2 in front, the x value is positive 2. Minus doesn't cancel, so it sticks around as minus 4. Okay, now the ordered pairs on this are the x value and this number we wrote, which is the y value. So we have ordered pair minus 2, 4, minus 1, 2, 0, 0, 1, 2, and minus 2, and 2, minus 4. And we can put these ordered pair on the graph. So minus 2 would be here, 4 would be right there. Minus 1, 2, 0, 0 is right here. 1, minus 2 would be down here, and 2, minus 4 would be down here. Okay, and then we can just connect these dots, and it's going to keep going like this and like this. And there would be our line. So this is just a straight line. There's no number out front, so the y-intercept is 0, and then the slope is minus 2, so you can also see that to get to any of these dots, you just go down 2 to the right 1, down 2 to the right 1, so you can also get it that way, or plug and chug like I did down here. Okay, now we're going to notice that this and this are exactly the same. If they were the same, if I didn't have that minus 4 there, then all these numbers I calculated would be the same. So what does this minus 4 do? This minus 4 is just going to subtract 4 from each of these blue numbers. So to get the green curve, g of x, we start at the exact same spot that we ended here, but now we're subtracting 4 from each one. So this is now 4 minus 4, which is 0. This is 2 minus 4, which is minus 2. 0 minus 4, which is negative 4. Minus 2 minus 4, which is minus 6. Minus 4 minus 4, which is minus 8. So we get new ordered pairs, minus 2, 0, minus 1, minus 2, 0, minus 4, 1 minus 6, and 2 minus 8. And we can graph those. So minus 2 is now 0, and then we have minus 1 comma minus 2, 0 minus 4, 1 minus 6, and 2 minus 8. And we can combine those and draw a line through those. And we see something interesting about these two. This is a special case of two lines. These are called parallel lines. And they're parallel. They look like train tracks because their slopes were the same, minus 2 and minus 2. But we also notice something interesting. What is the difference between the green and the blue line? The difference is that we just shifted. We shifted the blue line down 4. In fact, there's an even faster way to do this problem, and that is just start with the blue line. So you do have to do the work of picking some x's and getting some y's and then plotting that blue line. But then to get the green line, all you have to do is go down 4 from the blue. So let's look at a couple. From this blue dot, I would go down 1, 2, 3, 4, put a dot. From this blue line, 1, 2, 3, 4, put a dot. From this blue line, 1, 2, 3, 4, put a dot. So you can make your work really quick because you can just notice that these graphs are very similar. This one's just down 4. In fact, that's the answer here. G is just F shifted 4 vertically down. Okay, now unfortunately the other example I have to show you today is also a downshift of 4. So I want to show you what the other possible could look like because we're going to see 4 possible shifts. You can go down or up and then left or right. So let me show you what those would look like. So this one was, the function was minus 2x minus 4. So that was down with a minus sign. If it's up, it would be minus 2x plus 4. So notice the number is now added. If it's left, this one's a little trickier. The 4 is going to be next to the x. So it'll be x plus 4. And if it's right, the 4 will also be next to the x. It'll be x minus 4. And those are a little bit counterintuitive because we think of left as being the minus part of the graph, but in the shift, in a transformation, it actually shows up as a plus 4. And right, which we usually think is positive, it's the opposite in translations and transformations. If you're going right, you're actually subtracting the 4 from inside the x. Okay, so those are the 4 possible shifts we can see, and where the number, is it next to the x, is it outside of the x, is it plus or minus? Okay, 9 is the same way. We've got a slightly more complicated curve, so this is called a cubic. And we'll plug in some numbers and see what that looks like. So let's pick some x's again, and then f of x is equal to minus x cubed. And x numbers I'm going to pick are going to be the same ones we just did. Try minus 2, minus 1, 0, 1, and 2. Now, the first one I'm going to kind of show you with all the steps, and then I'm going to kind of shortcut it. Minus 2 in for x. So let's write that up here. What if x is minus 2? Well, we have a minus sign, and then we have x, which we're going to replace with minus 2, to the third. Well, in the last one, I just got done writing, if you have a negative number raised to an odd power, that's going to equal, the minus sign will stick around. So we're going to have minus from the problem, minus 2 to the third, the minus sign is going to stick around, so we have minus 2 to the third is 2 times 2 times 2, which is 8. So this 2 to the third is going to be 8, and that minus is going to stick around because it's an odd power. But now, because we have the minus out front, those are going to cancel, double negative, and the overall answer is going to be positive 8. So at minus 2, we have an ordered pair of y value of 8. Now, if you do minus 1 by the same argument, minus 1 to the third is minus 1, but then the minus out front is going to cancel, and you're going to get positive 1. 0 to any power is 0, and it can't be minus, so we don't have to worry about it. Now 1, if I take 1 in here, let's actually look at that one. it's minus 1 to the third. Well, this is supposed to be a minus sign here. Equal then minus. So 1 to the third is 1 with a minus in front, so we will get minus 1. So 1 to the third is 1, and then that minus out front will make it minus 1. Same argument, 2 to the third is 8, and that minus out front is going to make it minus 8. Okay, so our ordered pairs are minus 2, 8. So it would be minus 2, 8 right there. Then we have minus 1, 1, 0, 0, 1 comma minus 1, 2 comma minus 8. And we connect those with a smooth line. Smooth like that. Now, without doing any arithmetic, I'm going to make my life easy and say, okay, to get to the green line, I just have to go down 6. So we just have to go to each of these blue dots and just count down 6 and put a green dot. So we're going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then 6 down, and then 6 down, and then 6 down. And this would be the green one. So it's kind of hard to see with the curve, but if you were to shift all this, if you were to shift this blue line down 6, it would match up exactly with the green. And so we have to answer this again. We took it vertically down by 6. So G is F, just shifted down 6. Okay, now for 10, the last 3, they're going to give us the graph, and we have to answer some questions about it. So let's start with domain. So the domain is the x values that it can take on. Now to do this, you're just considering left to right. So I scan left to right and I say, okay, where is this graph drawn? So what x values do we have this curve actually drawn in? And so from the very left point, you're going to notice it starts at minus 2. So we're going to put minus 2 is where it starts. And then we go, where does it end on the right? It ends on the right at positive 6. So we put in a 6. And then we have two options. We can either use parentheses to encapsulate these, or brackets, or some combination of the two. We're going to use parentheses if these dots are open. So if it's like an open dot like that, we'll use parentheses. We're going to use brackets if those dots are filled in like this. So notice these dots are filled in, so we're going to use brackets. In fact, both of them are filled in, so we're going to use 2 brackets like that. Okay, let's look at the range. The range is the y values. So you're going to go from the bottom of the graph, let's actually write bottom to top. You're going to go from the bottom of the graph to the top of the graph. So we say, okay, and we're only considering y values now. So what's the bottommost point? It's right there. What's its y value? Minus 4. What's the top of the graph? It's right here. What's the y value? It's positive 4. And then by my same argument, because those dots were filled in, it's going to include those numbers, so we're going to use brackets. Okay, now the next one says, where's the x-intercept? The x-intercept is where the graph touches the x-axis. So we just have to go and scan left to right on the x-axis and see where does it touch. It touches right there. What's the x value? It's 2. So you would just put 2 there. Okay, the y-intercept is the next question. The y-intercept is where the graph touches the y-axis. And so we scan up and down on the y-axis, and we say, okay, where does it touch? There. There's where it touches the y-axis, and we record the y value for that, and it's minus 2. Okay, there's just one more question, And that's right. I'm not going to move the screen so we can see everything here. But the last question asks, what is f of 4? And they have it written right here. So f of 4 is asking, it's saying, let x equal 4, what is y? Let x equal 4, what is y? So to do that, we go on the graph to where x is 4, right here, and then we go straight up to the actual line, touch it, and then go straight to the left and read the y value. So when x is 4, our y value is 2. So the last blank, you'll just have to type in 2 for that. Okay, 11 is very similar. It's going to start with domain. Now, notice these arrows on this blue graph. This arrow means that this thing's going to go to the right. In fact, it's going to go to the right forever. It's going to hit every possible positive x value. It's going to go to 10, 11, 1,000, a million. And so we say it goes off to infinity. This arrow is interesting because it's slanted. So it's not only is it going left for infinity, in fact, we're going to say it goes to minus infinity, but it's also going up to positive infinity in the y. So that slanted arrow is going to give us two answers. One is an x answer, one is a y answer. Let's go back to the x answers. So for domain, I'm just scanning left to right. So as I go left to right, I say, where does my graph start? Well, my graph starts at minus infinity. And then I go to the right, and it slants down, and then it goes to the right some more. Where does it end on the right side? Well, it's going off to positive infinity. Now, I had mentioned in an earlier class to consider brackets or parentheses. For infinities, you always use parentheses because we can never contain it. So the bracket means, hey, your number could equal this value. But you can never, your x can never equal an infinity because it's there's not an actual number that represents it. Okay, now for the range. For the range, we go from the bottom to the top. So we say, okay, what's the bottommost of this graph? And you'll see that this graph is not defined anywhere below 4. So none of that's filled in. So the bottommost point is 4. Then we say, okay, what's the topmost point? Well, this thing is going to go up and up and up to, in red, positive infinity. Now we know infinities get parentheses. Now to decide on the 4, does it get a parenthesis or does it get a bracket? We have to say, does that blue line touch y equal to 4? And if you look very, very closely, it is exactly on top of the y equals 4 line. So it will be equal to 4, so we use a bracket. Okay, x-intercept, where does it touch the x-axis? Notice that this thing never touches the x-axis. So there will be no x-intercept. Okay, the next one's y-intercept. So the y-intercept, for that we go to the y-axis and we say, okay, when does it touch it? It touches it right there. Record the y value. The y value is 7. Okay. Now the last two questions are the, so plug in a number. So it says, plug in x is 2, what is y? So we go to x is 2, we go straight up to the graph, straight left, and record the y value. It's 5. And you just have to type 5 in your homework in the blank, and that should be all you need. And then for this one, we would say, let x equal 5, what is y? So we go to x equal to 5, go straight up, hit the graph, and then go straight left and record your y value. It's 4. So the last two answers on that one are 5 and 4. Okay, for the last problem, same questions, domain, range, x-intercept, y-intercept. The domain, okay, so this left to right, domain, left to right. This bottom slanted line is going to, it's hard to see it, but it is going to keep going left to negative infinity. It's also going to keep going down to negative infinity in the y direction. Now, on the right side, this arrow is going to keep going to the right towards infinity. And then in the y direction, we're going to notice this note here says graph approaches but never touches the x-axis. Never touches the x-axis. Well, the x-axis is the line y equal to 0. So that's going to play a role in our range. But for domain, notice our leftmost point is minus infinity with a parenthesis. Our rightmost point is positive infinity with a parenthesis. Now the range, which is bottom to top, the bottommost value is minus infinity, but then the topmost point is this thing is getting closer and closer to 0. So it's getting close to that x-axis, but it's never touching it. So the topmost point of this is 0 in the y. Now, keep in mind, I drew this arrow to the right, but what it really means is, what's the highest this thing ever is? The highest this thing ever is this x-axis, which is a y value of 0. So it's 0, and it's a parenthesis because it's never going to actually touch it. That part can be a bit confusing sometimes for students. They mix up their left and rights versus their up and down. So the highest this blue line will ever be is really, really close to the x-axis, but never touching it. And the x-axis is the value y equal to 0. Okay, now we got to get our intercepts. Let's erase this. Okay, the x-intercept, where it touches the x-axis. This says it never touches the x-axis. If it never touches the x-axis, there is no x-intercept. Okay, let's look at the y-intercept. So the y-intercept, where we touch the y-axis, which is right here, and we just have to record the y value, it's minus 1. And the last one says, when x is minus 1, what is y? So we go to x of minus 1, which is right here. We go down to the graph, we go back to the y-axis, and we record the y value, which is negative 2. So minus 2 will be the last answer there. And that should cover section 2.1.